In the previous lecture, we introduced the Population Stability Index as a measure that evaluates the difference between two populations. We explained how PSI can be used to assess if a population of a new loan applicants differs from the population of applicants on which the probability of default model was built. We also saw the formula to calculate it. Let's get down to business with some PSI preprocessing. We'll start with the original independent variables from our PD model and then move on to the overall credit score from the scorecard we created based on the model. Alright, first, let's import NumPy and Pandas. Then, we need to import the data we used to build the PD model. It's in the loan data inputs train CSV file. This is the original or actual population. Of course, we'll also need the new population. It comprises borrowers from 2015 and can be located in the Loan Data 2015 CSV file. First, let's create a new variable called Loan Data Backup and store the new dataset in it. Okay, I'll briefly complete several well-known steps. I'll start with creating a copy of the data called Loan Data. Then we can make sure that Pandas will display all columns. Finally, let's explore the dataset by displaying its head and go through its contents using the info method. Great! As anticipated, we'll need to preprocess the new data the same way we preprocess the train and test data. If the dummy variables are not exactly the same, the two datasets would not be comparable. Since we already have such a code, let's get going and copy it from the preparation notebook. Note that we will need to perform the general preprocessing and the PD-specific one too. Now that we have copied the whole code, let's paste it in our current notebook. I suggest that we run all the code until the part where we split the data. To assess population stability, we don't really need a train and test dataset. Alright, great. We have successfully performed the general data preprocessing. Now we can delete or simply comment all the code related to the splitting part. I'll opt for commenting out, as I don't really like deleting work. And it's done. Now it's time to start creating dummy variables for discrete and continuous independent variables. If you remember, we used this code cell here before. The variables that are employed in the code below are data frame inputs preprocessed and data frame targets preprocessed. The first time we used them, we made them equal the train inputs and targets. Then, some lectures later, we made them equal the test inputs and targets, and we took advantage of the parametrized code that follows. This time, we will set the inputs to everything from loan data but the good-bad variable. Obviously, the good-bad contains our targets. Great! Once more, we will start running the cells one by one and explain any necessary changes in the existing code. Okay, here's our first bump. Our attempt to create a dummy variable for home ownership, rent, other, none, and any generated an error message. It says one of the existing dummy variables we want to sum is missing. Let's see what the available unique categories of home ownership we've got in our dataset. Okay, so the error states that from the 4 categories we want to combine in one dummy variable, one is missing. In fact, if you dig deeper, you'll realize that 2 are missing, other and none. From a business perspective, this is strange and may in fact be an indicator of population change per se. Alternatively, since they are the categories other and none, we can assume that the bank has much better practices in place, so home ownership status is always recorded. Alright, since we won't be modeling, we only want to assess the population change. We can simply ignore this. The easiest way to deal with that is by using only the existing categories to create the combined dummy variable. Great! Now let's continue with the code. The next variable is address state. You remember this one, don't you? We preprocessed it for so long. Now the unique values are only 49. That's strange because in our original preprocessing we had 51, 50 for the 50 states and 1 for the District of Columbia. Let me save you the trouble and let you know that the 2 missing states are Idaho and Iowa. If you remember, when we were preprocessing the trained data, there was 1 missing state, North Dakota. So we actually know how to deal with this problem. We simply create the respective categories and set them to 0. Let's use the same expression to create 2 dummy variables for these states, Idaho and Iowa. Okay, now we can safely continue with the code, knowing that when we try to sum all the 51 dummy variables, we're not going to get an error that any of them are missing. Good job! Let's continue. Going through the rest of the preprocessing is rather uneventful. All other discrete variables behave normally, and we reach the point where we start preprocessing continuous variables. So let's continue running all the code relating to them. We stumble upon no errors. Awesome! We reach the point where we preprocessed the test dataset before. Now, let's create a new data frame called Loan Data Inputs 2015 and store the preprocessed dataset with new applicants. Let's also create a new data frame called Loan Data Targets 2015, storing the relevant information. Here are its columns, values of the inputs. And these are the shapes of the inputs and targets. They are matching, so we have worked properly. Just in case, let's save the 2 data frames externally in a CSV file. Great! Most of our preprocessing is done. What is left is to select only those dummies that were actually used in the PD model. This information is contained in the Inputs Trained with Reference Categories data frame from the Inputs Trained with Reference Categories CSV file. Since we need a similar file containing all dummy variables with the new data, let's call it Inputs 2015 with Reference Categories. Next, we simply take the same variables from the Loan Data Inputs 2015 data frame that we took during the training process from the Loan Data Inputs Train to create Inputs Train with Reference Categories. So now we have 2 identical data frames. Here are their shapes. The 2 have similar shapes, differing only in their number of observations. Alright, we mentioned we want to calculate population stability index not only for the original independent variables from the PD model, but also for its outcome, the credit score. The reason is that it is of great interest to us if the distribution of the score itself has changed. This by itself would be a sufficient reason to rework our model. That means we need to score both the trained data used to build the PD model and the new data. We have already scored the test data, so we can use that code to score these 2 data frames too. First, let's get the scorecard, stored in the DF scorecard CSV file, to the DF scorecard data frame. We want to multiply the dummy variables from each data frame by the scores from the scorecard. So, we need to add a variable that will multiply by the intercept to each of the 2 data frames with dummy variables. How can we achieve that? The first step is to create a data frame identical to Inputs Trained with Reference Categories. Let's call it Inputs Trained with Reference Categories with Intercept. Then we add a column in the beginning named Intercept, containing only 1s. After that, we order the columns of this new data frame in the same order as the features in the scorecard data frame. Analogically, we create Inputs 2015 with Reference Categories with Intercept identical to the Inputs 2015 with Reference Categories. Then, once again, we put the columns of this new data frame in the same order as the scorecard data frame features. Good job! Now we have to take only the scores from the scorecard and check if their shape is 102 rows by 1 column, in order to be able to find their dot product. Once we ensure this, we can use declare y_scores train and let it be equal to the dot product of the dummy variables from inputs trained with reference categories with intercept and by the scores. Okay. In the same way, let y_scores 2015 equal the dummy variables from inputs trained with reference categories with intercept multiplied by the scores. Alright. The first array contains the scores of the observations from the original trained data, and the second array contains the scores of the observations from the new data. Let's concatenate each of these arrays to the respective main data frame. Okay, they are now last columns in the data frames. And let's rename these last columns containing the score to, well, score. With this, in the last column of the two data frames, we have the score for each observation. That's great. There's one final thing we should take care of. As you know, we calculate the population stability index with categorical dummy variables. This means we'll have to turn score into dummy variables too. The scores range from 300 to 850. We can create dummy variables for each interval of 50 scores. That way, we'll have 11 dummy variables for score, from 300 to 350, from 350 to 400, 400 to 450, and so on, up to a category from 800 to 850. Once we do this for both data frames, we'll have categorical dummy variables for score as well. Great! We are finally ready to calculate PSI. See you in the next lecture.